All right, we're going to pick up with the other half of the worksheet, beginning with number 7. And here we are going to start with the first part of it. Negative x squared plus 4. Now, negative x squared would be a parabola swinging down from the origin. The plus 4 moves the vertex 1, 2, 3, 4 up to here. And this is where we start playing the game going down. Over 1, down 1. Over 1, down 1. Over 2, down 4. Over 2, down 4. Over 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the other one will show up over here. Now, this is only going to exist when x is less than or equal to negative 1. So that means that we're starting with a nice fat dot here. We're going down that way. And we can forget about the rest. So that is our first part. All right, our second part goes along y is 2. That's y is 2 right there. And of course, all of these dots, when it goes from negative 1 to positive 4, let's see, 1, 2, 3, 4, and it's going to make an open circle there. And it's going to make an open circle down here. And then it's going to connect all of these guys. And then the last one, x minus 4, that's 1x minus 4. That's going to start at 1, 2, 3, negative 4. It's going to start here. And with a slope of 1, up 1 over 1, and it's just going to keep going up in that direction. Now, it says that it begins where x is 4, 1, 2, 3, 4, and it's greater than or equal to, which means that it keeps going up this direction. It's going to follow this pattern right here. And we can get rid of these guys. So this is what the graph should look like when we're done. And one of the things that I hope you've noticed is that I tend to focus on the endpoints, like where x is negative 1 and x is positive 4. Those were the endpoints that I focused on, assuming that they were going to connect in between. And sometimes, like in the case of the parabola, I sort of sketched out the dots of the full parabola, realizing that I'm only going to use some of them. And those are the ones that I focus on, those are the ones I highlight. I kind of do it lightly so I can go back and erase it after the fact. And nobody can tell what I did. All right, number 7. On to number 8. Oh, this is the same one, but we have to solve each of these problems. Negative 2 is definitely less than negative 1. So we're going to find out what is negative. And you have to be really, really careful of this. Because when you do this, this is what you are actually doing. The negative sign does not automatically cancel out because of the negative 2. So when you square negative 2, you are still left with negative 4 because there's a negative waiting on the outside. As soon as this becomes a positive 4, now it's negative again. So that is 0. Now, negative 1. Oh, that's a sneaky one because you've got a negative 1 here and here. And you got to figure out which one, if x is negative 1, which one does he belong to? That looks like an open circle. That looks like a closed circle. So we're going to do that and that, square it, and add 4. Which means we're looking at negative 1 plus 4, which is 3. All right, 4. We have to figure out which one of these is 4. Actually, he's going to wind up being this one. is greater than or equal to. So 4 minus 4 is 0. And then f of 9 would be 9 minus 4, which is 5. All right, we've got to write a piecewise function for the graph below. Now, first of all, I want you to notice that this guy is following that pattern of up 1 over 1, or excuse me, over 1 up 1, over 2 up 4. And so this is definitely a parabola, but the vertex has been moved. All right, let's start the beginning language here. And we're going to say that it's been shifted 2 units to the left, which means I'm going to do that. And it's been shifted up 1 unit, which means I'm going to do that. Now, all we have to do is figure out, this starts from a solid circle where x is -1, and it goes down. So basically, x is below -1, and it's also equal to it. Now, for this guy, it's a straight line, which means that we're looking at, something like that. My first step is to figure out what's the slope. I went down 2 and over 1, down 2 and over 1, down 2 and over 1. That's my slope. So I'm going to say -2x, and I notice that it crosses the y-axis at -3. So that's the equation, y equals -2x minus 3. Now, we notice that x is anything above -1, but not equal. Green is equal. And so that should be the majority of it. All right, write a piecewise function for this guy. Now, I have to say that this is going to be a little bit of a challenge. First of all, I'm hoping that you'll recognize that this is the parent function. But I also want you to notice that instead of doing from here and going straight up that way, like it would normally do, it's going up 2 over 1. There's a definite slope to this that is not just 1. As a matter of fact, it is being stretched by a factor of 2, up 2 over 1. So, we're going to start with this guy. Now, his vertex got moved over 3 units to the left and down 3 units. So we're going to say that 3 units to the left is going to do that, and down 3 units is going to do that. Now, as to the stretching, the vertical stretching by a factor of 2, that should look like that. Now, it wouldn't hurt to try out a couple of points. For instance, if I try out x is 0, well, x is 0, and 0 plus 3 is 3, 2 times 3 is 6, 6 minus 3 is 3. So that works. Trying another ordered pair, -3 and -3. If I stick a -3 in there, I get absolute value of 0, which is 0. 2 times 0 is still 0. 0 minus -3 is -3. So this is definitely working. Whenever you have qualms about whether your scale factor is working or not, try a couple of points in it and make sure that it works. Make sure it does what you think it's going to do. Now, let's try the other guy. Doesn't this guy seem to be parallel to him? But the question is, well, I guess you're not going to call this an absolute value because it's just a straight line. This is just, oh, and I almost forgot. We forgot to define our x. Is anything x above, x below 0 or equal to 0? Less than or equal to 0. All right, now, this guy, even though he seems to be parallel to this, and you're going to want to try and write this in terms of an absolute value, there's only one side of it, which means we just got a straight line. This is going to be y equals mx plus b. And it ought to be fairly easy because we've already figured out the slope is 2. He's parallel to this other guy, up 2 over 1. So that's going to be 2x. And he crosses the y-axis at -1. And he is anything above 0. Be careful of that. It's not the -1. Now you're paying attention to x. So he's going to do that. Okay. Now determine whether this is continuous or not. Well, my first ordered pair, I'm checking out the ones. I have 1 and 4. Now, when I plug this in, 4 times 1 minus 4 gives me 0. Which tells me right there I can stop right here. I have one stinker that does not match. So I know that this is non-continuous. All right, let's try another. When I try -3, and when I try -3 over here, both of these wind up with -3, -8. So far, so good. But I've got another place that I've got to check, and that is these guys. So what happens when the middle guy is 2? 2 times 2 minus 2 is 4 minus 2, which is 2. And then for the last guy, 3 times 2 minus 4 is 6 minus 4, which is 2. So for these guys, I'm going to get 2, 2, and 2, 2. Now I can say, yes, it is continuous. All right, this is the last one. So we first focus on these two. Try and figure out, well, the first guy, easy peasy, that's going to be -4 and 12. But when I say 8 minus -4, be careful of that. That's 8 plus 4, which is 12. So far, we're good. Now I got to check the other guys. 8 minus 4 is 4. 20 minus 4 squared is also 4. We have a continuous function.